Thank you. So I know this is a bit late. You just had lunch, so thanks for attending this session. I am Ananias, and I'm going to talk about MySQL on Kubernetes, how to deploy on Kubernetes, how to scale, how to set up backups, and how to go through some advanced configuration items. I was initially expecting to have a hands-on session, but since we have many talks, which is great, we're only going to go through the presentation. So first of all, let me introduce myself. I have a bachelor and master in computer science. I have 15 years of experience as a systems and databases administrator. I joined Percona back in 2017. I work as a principal DBA, mostly focused on the MySQL ecosystem, and I'm coming from Greece. And as said before, this is the agenda. Why to use MySQL on Kubernetes, how you can deploy that, and whether you should do that on your own or there is a better way. How to deploy MySQL on Kubernetes using the Percona operator. We will talk about scaling, backups, and advanced configuration. So MySQL on Kubernetes. I think Peter talked about that, about Kubernetes, why we use Kubernetes, what's the value. As you most probably already know, this is the most popular container orchestration platform. Do you have any experience with that? Have you ever used Kubernetes? OK, thank you. And what happens? This is what developers need. They want the databases to be simple, just have an endpoint, just connect to a service, and do what we want to do. What DBAs want, they want their databases to be secure, to be reliable and consistent. And of course, what the end users want. They want the applications to be fast and, of course, always available. And we can do that on Kubernetes. The first option is to do it on our own. That means create everything from scratch. Or we can use Kubernetes and operators. I think Peter mentioned about the value of an operator for day 1 and day 2. And what are the Kubernetes operators? Kubernetes is aware and can easily be used for stateless applications. For example, web applications where you can destroy the pods. These are called pods, and just create new ones. But does not have knowledge for stateless applications. And this is where the operator comes. Actually, operators are software that extend the Kubernetes functionality. And the operators use custom resources to manage applications and their components. And what is one of the main advantages of the operators? All the tasks that these perform are performed in a consistent and reliable manner. No matter how many times you will perform the same operations, this will always be consistent and reliable by using a set of best practices and rules. So we define what the best practices, we define the rules, and we have some expertise on that. So we deploy the service in the best possible way. And Percona offers operators for MySQL, Mongo, and Postgres. Especially for MySQL, there are 2 variations. The first one is based on the Percona server for MySQL, and the second one is based on PXE. What is common between these 2 operators, or between the operators? These are open source, and the same applies for the components that the operators rely on. The PXE one is production ready, and there has been great progress on the one based on Percona server for MySQL, so we are almost there. What are some key features? You get a service with load balancers integrated. Depending on the use case and your needs, you can either pick HA proxy, which is the default balancer, or proxy SQL. You have easy integration with Percona management and monitoring system, the PMM. You can deploy multi-cluster, and you can create multi-cluster and multi-regional deployments. You have point-in-time recovery, and there is an implementation for upgrades. You can easily upgrade your cluster, and there are multiple options available depending on what upgrade strategy you want to follow. Of course, these are some of the key features. I think the most important ones. There are some more that I'll explain at the end. And how to deploy on Kubernetes, MySQL. The Percona operator makes it easy to deploy, highly available. The service will always be up and running. Self-healing, if something goes wrong, the operator will try to recover the service. And scalable cluster. That means if you need more or less resources, you can adjust based on your needs with a load balancer in front of the cluster. The deployment happens in a consistent and repeatable way. No matter how many times you will deploy, it will always be deployed using exactly the same way based on the configuration you've made. And the operator uses YAML-based configuration, and this is just an example for PXE, assuming that we use the operator based on PXE, where I think it's obvious that these are the PXE nodes with a size of 3. This means a cluster consisting of 3 PXE nodes. This is the image that will be initially used. These are the resources, so it can use 1 gig of memory, and 1/3 of a CPU, approximately. We also have some affinity rules. For those who have already some experience with Kubernetes, these are some terms you may be familiar with. But for those who are interested in exploring Kubernetes, that's something you will need to get an idea when you start deploying. And this is for HA proxy, which more or less we have the same options like the size, the image, and the resources. And assuming that you want to deploy MySQL and Kubernetes using an operator, first thing is that, of course, and this is the case with every software, every deployment you have to do, you have to verify the prereqs. The operator has been tested across various platforms, various versions, and since there are too many, there are different infrastructures for Kubernetes, there are different versions. Just ensure that you are following the documentation and you are deploying on versions that have been tested. You should also review the configuration for the services and the deployment and make them match your needs. For example, there are the affinity rules that define how, let's call them, DB nodes will be deployed across your Kubernetes infrastructure, or the load balancer nodes. These are called pods. What will be the sizing, for example, how many nodes you will have, and the capacity, what resources you will allocate to the pods. And you can optionally select the balancer. As said, HA proxy comes as default. If you don't make any adjustments, you will get HA proxy. If you want, you can switch that to proxy SQL. You need to, if you want, you have to enable the PMM client. All you need to do is to specify the PMM server endpoint and the credentials. And when a new pod will be created, it will connect back. I think this part was explained during the PMM presentation, how it works. You can configure and schedule the backups and adjust the services configuration. These are not required at the beginning, but you can do that if you want to have everything deployed from scratch. And talking about services configuration, the operator has some logic, has some rules. So, for example, depending on the amount of resources that you will allocate to the database nodes, there will be some adjustments to the running configuration for MySQL. For example, if you allocate 1 gig of RAM, then the InnoDB buffer pool will be configured accordingly. Or depending on the hardware resources, you will have a max connection setting. But if you want, or if you have any needs for specific configuration, then you can edit, of course, the configuration of MySQL. And as said, even if you don't make any adjustments, the services are designed to work out of the box. So you get a service IP or host name, and you just point your application against this service host name, and you will get connectivity to the database cluster. And this is an example where, as you can see, with 3 commands, it's using Helm, I can have a full cluster up and running. So what I did here, I just added the repo, I installed the operator, and then I created the cluster passing some custom configurations. So I've allocated this amount of CPU, I've set an affinity for both PXE and HA proxy, which is the load balancer, and I've decided this is just for demonstration purposes to keep backups disabled. And what I get, kubectl is the command that is used for Kubernetes. I get, for example, the pods, and this output shows me that I have a 3-node PXE cluster here, and another 3-node HA proxy. And this ensures that at every moment, I'll have 3 PXE nodes available and 3 HA proxy nodes available. If something goes wrong, if there is one HA proxy which is unhealthy, this is something that the operator takes care of. It performs some health checks, and depending on the health check status, if it detects for any reason that the node is not healthy, the pod will be terminated and another one will be created. So at the end, I will always have 3 HA proxy and another 3 for PXE. Again, depending on the configuration I've set. If I ask 5, then it will always be 5. And what about scaling? I think this is something we already know. Add or remove resources. And why to do that? Either for architectural reasons or for performance reasons. I want to add more nodes because I want better performance, or I have a new data center and I want to deploy Kubernetes on a new region, or for capacity reasons. And items to scale, number of pods, how many DB nodes I'll have, or balancer, how many HA proxy nodes I'll have. Or what else to scale? The resources. That is, I want to give more memory, or I want to add more disk space, or I want to add more CPU because I have more traffic. And how to scale? If you remember, I showed you kubectl before. For Kubernetes, kubectl is your friend. Whatever you want to do is kubectl and some commands, or kubectl a command and a YAML file. And for pods, you can just patch running configuration. So kubectl patch is a command, and I patch the configuration. Or I can edit the cluster name and change the value I want, for example, the size or the CPU and the memory, and just apply this configuration. And what happens at the end? The operator will apply the changes, the pods will start recycling, and then a pod will be terminated and replaced by another pod with the new resources, if resources is what I've just changed. For persistent volume claims, that is, in short, the amount of disk space available to the pods, the operation is a bit more complex because it depends on various factors such as the storage class or the driver and a few other configuration items like the finalizers. So these are things that you should be careful with. Backups. The operator supports two types of backups. Actually, there are physical backups and point-in-time recovery. For physical backups, extra backup is the tool that is being used. And for bin logs are used for point-in-time recovery. And the binary logs are being pushed to a backup destination every X amount of seconds. This is something that you can configure. But you need to configure that wisely, because when we stream backups, there are some special operations that may affect your cluster, because, for example, we flash the binary logs every X amount of seconds. The backups can, but I'd say should not be locally stored. We should not forget that in the Kubernetes world, everything should be treated as ephemeral. We shouldn't rely on a single worker node. So if this node goes down, we lose everything if the backups are there. And in case of a disaster, we should be able to recover to another cluster from another location. So my recommendation would be to use an S3 bucket or an S3 compatible storage. And this is what happens with backups. You can either manually execute on demand, or you can create your own scheduling. And this is, as said, a YAML configuration. For example, for backups, I have defined that this is an S3 bucket. This is the bucket name, the region, and this is where the operator will get my credential. And if I want to have scheduled backups, this is like a regular cron. So I have a name here, and these backups are going to be executed every Saturday late evening. And some advanced configuration items. There are too many. That's not possible within a 25-minute session to present everything, but I think that's a good starting point for further evaluation. You can pass custom configuration for services, like MySQL variables for performance or connections, or HA proxy if you want to create complex setups, or proxy SQL. This is something fully supported. You have affinity and tolerations, so you can control the way that the pods are deployed across your Kubernetes cluster. You can, for example, have some nodes that have faster disks, SSD with high capacity. You can set some rules. So what happens in this case? The pods will be deployed to these nodes. The operator will use some logic, and it will follow the rules that you've set. And since this is a database cluster, you need the worker nodes that have the faster disks. Local storage support. If you want, for any reason, you can make storage available to the worker node available to a pod, so the pod can save data locally on the worker node. You have support of environmental variables. If you want, for any reason, to pass environmental variables, either passwords or tools or versions or whatever it may be necessary for your application, you can do that. So you store the variables in the Kubernetes. You submit through the Kubernetes API using the operator, and these are available to the pods. You can use config maps, for example, and use the variables that you've set. You have transport and data at rest encryption. So you can use the normal stuff like TLS, SSL for the transmission of data. And you can also save the data encrypted on disk. You have upgrade strategies. For example, you can instruct the operator to automatically apply minor version upgrades when there is a new version. And this is really helpful if you want to mitigate security vulnerabilities that are really critical and you don't want to miss this. But of course, I understand this is a trade-off between having automated upgrades versus manual upgrades, but at least we have the option. So depending on the service and how critical it is, you can follow different strategies. Or you can completely disable automatic upgrades. And of course, we have support for sidecar containers. So that means if for any reason, it may be some tooling, it may be debugging, it may be whatever, you can create your own containers. These are called sidecars, and spin these containers inside your Kubernetes cluster. So that's all. I think I'm on time.
A little bit. We have a couple of minutes for questions.
Do you have any questions for me? Yeah, sure. Okay.
In this Kubernetes cluster systems, how we manage master-slave relation?
When it is Percona server for MySQL, right?
Yeah.
Master-slave?
Yeah.
Is this the question?
Yeah. In the end, there's also we are using Kubernetes in MySQL cluster, right? And top of that, there's a Percona.
Right.
Right?
There is orchestrator. I mean, there's the initial deployment. So the operator configures who is the master, who is the slave.
Okay.
And if something happens, depending on whether this is the primary or the replica that failed, then the operator creates a new pod and relocates the replicas and connects them back under the new primary. Or if it is just a replica that failed, it terminates the replica and creates another one, and then this replica is connected to the source.
If master disconnect, also it solves that issue?
Yeah.
Good. I want to ask, is it safe to use big databases like terabyte levels?
Yeah, that's a hard question. I think we had a discussion before. Kubernetes, and of course the same applies to MySQL, right?
Yeah.
Or PXE or whatever it may be. There is no single question. And I'm pretty sure you've heard already this, it depends. So you may have big amount of data, but depending on the operations, it may not be a really good fit. But there is no single answer I can give. What you need to keep in mind is that, for example, for the PXE operator, there is a synchronization cost. So if any of, let's call them database nodes, okay, this is a pod. If any of the pods goes down, then the operator has to create a new one, start the syncing process. That means copy 3, 5, 10 terabytes of data, and this operation may not be ideal because you are transferring data, you have the synchronization process. So from my perspective, such a huge amount of data is not something you should fully migrate there unless you have done some evaluation on how you are going to use that. If this is just a huge data set, but you are not performing huge operations or so intensive operations, or I don't know, you can do that.
Thank you.
Okay.